In this video, we're going to continue our discussion of classes. Classes in C++ are a very important part of, of what we do as programmers. And looking forward to the next class that we'll take in data structures, classes are very important as well. Okay. Also, today we'll talk about abstract data types that will come later. This may be a bit of a long video, but again, this is important stuff. Okay. So I want to start with just a review of how I build a class. I think it's important in anything we do in life, but certainly in programming, to develop habits, to develop a routine so we don't forget stuff. Okay. So this is kind of what I do when I create a class. So this class, pretty basic. We can describe it pretty easily. I want to describe a circle class. So when we're doing a class, we're thinking of what kinds of objects we want to capture. In this case, we want to capture a circle, the geometric circle. So we'll have individual circles we create. So in order to describe a circle, we're going to need a radius, which we'll use as a double. Okay. And I'm going to add a color to it just so we have a little bit more to deal with. Okay. So I start here with my class circle. And by tradition, and it's important, traditions are important in computer science because it allows us to kind of know what to expect. So by tradition, we take a class name and make the first letter a capital. Okay. You don't have to do it. It doesn't not work if you don't do it, but it's a sign to other programmers who may view your code that this is going to be a class. So this particular class, I've went ahead and put in the beginning and the end. I always forget the semicolon, so I went ahead and did that. And I'm going to go ahead and say end class circle down here, or end circle class probably. It's a little cleaner. Because this time, unlike the previous example, I'm going to go ahead and define the functions inside of the class itself. Okay, so I think when you do that, sometimes the parentheses or the ending curly brackets get a little confusing. So we're just going to make clear what we're doing there. Okay. And it seems like people often start with public, and I guess that's okay. It doesn't really matter. I'm going to go ahead and start with the private just because to me, this is the heart of this class. So the private is going to let us know what does a circle. So what does an instance of the circle class, what does it need to remember about itself? Okay, so in this case, we're going to need a double for the radius. Okay, and we're going to have a string for the color. Okay. And I've gone ahead and included the CMath here because when we're doing our calculations of the area of a circle, we're going to need it. Okay. And I guess if you want to be more in tune with the rest of the world, we can go ahead and do a public. If I can find the home keys, public right there. Okay. So for the two private member data I have, it means that, so down here in int main, I can create circle C1, for example. Okay. But what I can't do is this. I can't see out C1 dot radius. Okay. Or I can't use C radius in any kind of a formula here. Okay. So because they're private, and that's one of the points of a class is we can protect that. Okay. I have to have two things. I have to have accessors. I have to have mutators. And there's often other functions that we have. So I go ahead and put those in at first so I know where to look for them. I'm documenting where they are. Okay. And we have a choice to make here whether or not we want to have accessors in particular for all of our member data. Okay. So in this case, we're going to, but it is a choice. Sometimes you don't want outside users or other programs or any other part of the program to be able to access the internal values at all. Okay. Things that don't change. Okay. So accessors allow us to see it again, and mutators allow us to change it. Okay. So these always have this form. So let's start with the accessors. Okay. Get name of the member data. Does it have to be this way? It does not have to be that way. But again, programmer practice says that it is. And the fewer things you have to worry about in programs, the better. So I just know what's the accessor going to be called for radius? Get radius. Okay. So the return type of this function is always the return type of the member data that we're returning. Okay. Takes no parameters. Always. They always look that way. Okay. The function is as simple as can be. I just return radius. That's it. Okay. So again, here where my blue cursor is, I'm inside of the circle class. So I'm able to access radius. Down here, I'm outside of the circle class and I'm not. So that's why I need the get radius. Okay. All of your accessors look more or less exactly the same, except for the type and the name of the variable. So I'll go ahead and copy that. Going to paste that. Going to do one on this time. It's going to be a string. If you get color, and it's going to return color. Okay, done. Easy. Okay. Mutators. A mutator function is a void function. Okay, it doesn't return anything. What it does, it changes. So this is going to be set radius. Okay, and it's going to take some data element or some variable of type whatever we're trying to model. So radius is a double, so we're going to take a double. I'm just going to call it R. Okay. At its simplest level, we're just going to say radius is equal to R. And we're going to say the color is equal to, let's see, we want to make it red. Nope, wrong. Getting too much. Just the radius equal to R. Getting ahead of myself. Now we do a void set color string C. We're going to set color equal to C. Okay. One thing I've seen a couple of you do of late, you want to watch out for, the order of this is important. Okay. This is not in math where we can go either way. Okay. This is an assignment, not an equality. I'm saying sign radius. So radius is the class member. Okay. To the value of R we're sending in. Okay. So it's got to be radius equal R equal radius will not do it for us. Okay. So that's going to be those two. Okay. So let's think a little bit more about this set radius. Okay. So let's assume that the radius needs to be greater than 0 because I think it does. We did a rectangle example where we were in fantasy world where we could have negative or 0 lengths, but we're not going to do that. So I'm going to go ahead down here when I'm defining this and make the stipulation must be greater than 0. Okay. Which means when I go to set radius, I have to do the following. Say if R is greater than 0, life is good. We set the radius. And then what we typically do, we'll just do like an else. We could put in a message here, see out. Radius not greater than 0. Is that really a 0? Hard to say. Yeah, 0, put 20 on my screen. And then we're going to see out setting to default of 1. Okay, and these are programming choices we're making, but we can certainly do that. Okay, and then of course I have to actually do that and say radius is equal to 1. Okay. So setting the colors more difficult. It's a string. They really can do whatever they want. If you really wanted, you could put in a enumeration, which we talked about, but we're not going to bother with that. Okay. So that's good. We're fine for now. We can now go to the other functions that we want. And again, if we had a UML diagram, we'd be able to look and see what we needed. But in this case, let's say that we want to add something to do the area. Okay. And it depends on how people do things. Sometimes people will call something like get area, or sorry, set area. Or no, sorry, get area is what it would be. but that implies that it is an accessor and it's not really, it's something new. So I just like to call it area. Okay. So the area is going to return a double. Call it area. Takes no parameters. Okay. Again, because it's inside of the class, it's able to read what we're doing. And I could set up an area variable here if I wanted, but we can also just return direct. So this, I'm just going to go ahead and return. Okay. Since we've included the CMath, we can get to the m.pi, which is built in the CMath library, which is as many decimal places of pi as the system can hold. So it's a good way to go with that. Times, and I could just say radius times radius, but I'm going to go ahead and use the power function radius 2. Okay. That's all it needs to do. Okay. If it's unclear, you can always put a comment in here. And you can give the formula if it's weird. This is not weird. We don't have to worry about that. Okay. So we've got that one, and let's do one more while we're at it. It's never a bad idea, I don't think, to add a print function here. So I'm going to have a void function, print circle, takes no parameters. This one I'm going to see out. That's what it is. Description of circle. New line character before it. And you can decide how you want this to look. Okay. This doesn't violate my rules about printing in functions because all it does is print. Okay. Then I'm just going to put the basics here. Radius of the circle. Put a tab to make it look neat. And then the radius, and then end line. Okay. And then I'm going to do the color. Tab. Sometimes with tabs, if you have different labels, you have to go back and put more tabs for some than others. Okay. And while we're at it, I mean, why not? I'm gonna go ahead and put in the size. You don't have to do that. That makes it in some ways less general, but :T, that's what I want. Okay. And the area returns a number, so I can go ahead and just call it there, and it will create that function. Okay. So these are the basics. Okay. So as I've created my circle down here, so I need to test it. Okay. So I've got it. This means that I have to test all of the functions. And you can think about ways to do this. So it probably defaults to 0. So I can go ahead and do like a C1 dot print circle. Okay. And that should show me the initial values of that. Okay. And then I can test the accessors. So I can do a C out of C1 dot get radius. Again, this is not a program I'm using. This is testing this function. And then I can C out C1 dot get color. Okay. And those should be the same as we just got from the print circle, which we just tested that as well. Okay. And then we're going to test the mutators. Okay. So I'm going to do C1 dot set radius. Going to send it a 3.5, let's say. Then a C1 dot set color. Set it to blue. Okay. And then I'm going to do a C1 dot print circle again. Okay. And the print circle will test the area function as well. So you can do a specific test of the area function, probably better, but for time's sake, I'm just going to keep it like this. Okay. And with my new radius of 3.5, I can go ahead and get an idea. I popped up my calculator on my phone here, 3.14159 times 3.5 times 3.5 should be equal to 38.4 or something. Okay. So that'll give us an idea of whether or not we're working. Okay. So now let's compile it and see what all crazy typos I made. I made one. There we go. I misspelled it or mistyped it. So the question is, did I call it the wrong name or did I just type it? That looks okay. It must be where I actually, yep, that should do it. Okay. Put it here and we get the default, and this is showing us as well, our defaults are a radius of 0. We can't assume that, but that's what it's doing for us here. And it's printing out the color, which there's nothing there, so that it's blank. Okay, that could be random stuff too. The size is 0. Okay, we're then printing out the radius. That's what this was, which is 0. We're printing out the color, which is nothing. Okay, and then after we've done our mutate, we see that yes, it did change it to 3.5. So the set radius worked. The set color did set it to blue. And here's our radius or our size with radius of 3.5 is correctly at 38.4845. Okay. Feel pretty good about that number because I checked it with my calculator. Again, you could, if you wanted, you could do a set precision, set that to a certain number of decimal places. That would be fine. Okay. So it's in this area here that I think we have some issues. It's that our default position when we first start is 0, which is an illegal circle by our definition of radius. Okay. So there's a problem there. So the way to solve that problem is something called a constructor. Okay. If you've had Python, the constructor is like the underscore underscore init underscore underscore function. And it's basically what activates or what runs as soon as you create your class instance. Okay. So for example, in this case, where it's going to activate is on this line right here. Okay. So on this line, it's going to run a constructor. Okay. Well, we don't have a constructor. So what does it run? There's a default constructor that the C++ compiler will add for us. The default constructor does nothing but set the initial values to the variable types, which usually makes integers 0 and it makes strings blank. But again, no guarantees from system to system, especially. Okay. So we want to go ahead and create these functions. Okay. So these are public functions. Okay. And they're a little bit different. The first thing that's different about a constructor is that there is no return type. Okay. But it's the name of the class. Okay. So we can do a circle. And let's say I want to set a double R for the radius. And I want to set a string C for the color. So we could here go ahead and set radius equal to R and color equal to C. But for the radius, we would have to go through and replicate, seeing if it's greater than 0 or not. So an easy way to do it, and I think a better way, is to use the set radius function here on R. Okay. We can do the set color. See, we do it right away. So not only do we not have to retype or cut and paste whatever logic we're using to restrict our variables, there's no chance we're going to make a mistake. If so, we've made it once, not twice. So copy that. Instead of copying that, just call the set radius and the set color. And that will happen whenever we first make an instance of the class. Okay. So I can change this down here. And the syntax is that when I'm calling the circle, I'm going to pass along those parameters. So I'm going to pass along, let's say, a 5 and a blue. Okay. Once we've done that, we can run it. If we haven't made any mistakes, it should work. And we see our default is 5 and blue. Okay. It happened that we changed. That's kind of unfortunate. Let me change it to a different color. We set it to blue both times. In a blue mood, apparently. Not really. Yeah, you see the blue at both places. Let's go green instead. A little better test. Okay, now we have green, and now we have blue, and things are different. So that's good. This solves a problem, but it also creates a problem in some ways. And it doesn't, well, I guess it helps and doesn't help. So let's say we want to create another circle, just a default circle. We want to allow that. We would think maybe that's going to call the default constructor, but it doesn't. If you have no constructors created, then it will call the default constructor. But as soon as we've added one constructor, which we just did, it takes away the default constructor. And that may be what you want. You you don't want someone to be able to create a circle without specifying things. But the other option is that we can create another constructor that takes no parameters. So when we do this, we're able to set default conditions. So I can set radius is equal to 1, let's say, and I can set color equal to. Okay. And you may want to put down here that this must be greater than 0, that default 1, and here you may want to say that default is red. Okay. That way you know what's going on. So now both of these should work. And they do. I didn't print my other circle, but like we should do that. So the last thing we'll do at the bottom do a C2.print circle. And that should show us the new circle that we created by default, basically. And there it is, the 1 in the red. And that, of course, is 3.14159 because that 1 times 1 is 1 times pi is that. Okay. So that's what a constructor does for us. There's another concept called a destructor. And the destructor is what happens when a object goes out of scope. At this point, there's not much need for a destructor. So we'll talk about those later. So when we get into having memory structures, such as arrays and other things, as part of our classes, then we have to worry about releasing that memory, and that's where the destructor would come in. So one other thing I want to talk about when we're talking about classes is that, and when I do the class this way, there's a whole lot of stuff before we get to the int main. And we certainly could do like the book does and put all the functions below int main. And that's fine. But classes are often used across multiple programs. Once I have a class object, there's no need to recreate it 1,000 times. So I can create my own class library. So what does that look like? So the first thing to do, and for me, I took this working program and I copied it twice. Okay. The first thing I copied it to was just called circle, capital C, dot CPP. And then I basically got rid of everything. So here's all of um, the things I had before. So I still need the include IO stream. I need the include CMath. I need the including namespace standard. Okay. I then have all of the class stuff that I've copied over. And this was from the previous version. It may not be exactly what I had, but same basic idea. Okay. So notice that there's no int main. When the class is done, that's it. So this function starts with our includes, our preprocessor directives. It does the class, it ends the class, and it's done. Okay. So if I were to compile this, the only error it gives us is undefined reference to main. And we don't have a main, so that's fine. So that's a way to let you know that your classes are kind of working. Okay. So the other thing that we can do here, then I've created this test program. I call it the same name as the class with the word test. So it's circle test. So again, has to have this. But notice that I'm including the circle.cpp. So this will, we talked a little bit, but we can review the preprocessor directive. When it sees the octothorpe here and the word include, it finds that file and puts it into your code. So when the IO stream is code that's out there in the C++ library, as is the CMath, they're now all part of my program before it gets compiled. I'm now taking my circle.cpp, copying all that over. So it's just like that code is here in this program. So it should work just fine. And then we're able to, this is the same program we had before, at least the same one I had. It's a little bit different, but I did this one first before we started. Okay. So now if I want to compile that, and then run that, and there we go. So it works. This is the version I had before, but this is the same basic idea. Okay. So the other thing, and I'll look at that example as well. Other thing that we can do here, once we have, that's not what I wanted. I wanted to exit. Because you see there's different stuff in there than we were talking about. Lots of comments there. Just for me to keep track of things. So what I've done differently in this version of the program is down in int main, testing all that stuff. Starting with here. So what I'm doing now is creating an array of circles. So once you've created your class, you can create an array of objects of that type. So that's what I'm doing here. So I'm setting my constant integer size equal to 5. I'm then doing a circle, my circle to size. Okay, so that's an array of circle objects. And once I've done that, if I wanted to go through and set the radius for all of the circles in the array, that's a little problematic. You could go through and ask the user every time. In this case, I just want to say I want to have circles of radius 2, 4, 6, 8, whatever. I noticed before I had an error in this code because what I'm doing is I'm saying for my circle sub I, that's a circle object in the ith position, starting off at 0, to set the radius to I times 2. When this starts at 1 or 0, it sets it to, tries to set it to 0. It then defaults it to 1, which is a good test that that's working. But I think it makes more sense to go ahead and set this to 1 and go up to size plus 4. Okay. So now I'm going through and creating, this creates the circle array up here. Down here, I'm assigning values 2, 4, 6, 8, 10. And here I'm just printing them out and doing a print circle on all those. That's why that other printout looked a little bit different. I'm not dealing with the color, so the color is going to be whatever our default was, which I think was red. Okay, so if I do G++ on simple class, now you'll see that it's going to go through and create. Here's we're printing out the circles of the array. We set them all. So the array is 1, 2, 4, 6, 8. Oh, that's weird. This didn't have that problem before. There's an issue with that. I won't spend too much time looking at it, but when it was 0, it didn't give me that error. So let me change that back. So change that plus. It's probably that +1 that's giving us an error, but I'm not sure. Let's see. Yeah, that works okay. With the 1, then the 2, then the 4, then the 6, and the 8. And it gives all of the radiuses for that. Yeah, that +1 was giving it some trouble. I'll have to think about why it was doing that. Okay. But you can do arrays there. That's the idea there. So you can do arrays of objects. And that's a pretty common and pretty useful thing to do. So the next thing, I guess the last thing, it's been a long video already, we want to talk about is this idea of an abstract data type. Pull up the example here. So some of this is from the book, some of this I've written myself or rewritten myself. So an abstract data type is a data type. And the main thing, the abstract part, we see this a lot in programming. It separates the logical properties of the data from the implementation. Okay, so we're able to view at a higher level what the data is supposed to do as opposed to how it actually gets done. So when we're creating an ADT, there are 3 things. Again, we're going to do a whole lot more of this in data structures. So the 3 things are the name of the ADT, whatever it is, the domain, which are the set of values that belong to the ADT, and then the operations, or what we can do with the data. So here's an example of what an ADT would look like for a list. So we know we have lists in Python if you were in the Python class. So that's good. We don't have a list in C++, so we're creating a list kind of thing. Okay. So the list that we have still is going to be limited to the same type of data. Say we don't get that from a list, but we can add some other stuff to it. Okay. So this is the abstraction of that list. It's going to be called list type. The domain is, we can make it up, that every list type is value is an array of, say, 100 numbers. We could say 100 integers. We could say whatever it is. It could be a list of strings. Okay. The operations on this list that are not there for us if we just did an array, check to see whether the list is empty, see whether it's full or not, to search the list for an item, to delete an item from the list, to insert an item into the list, sort the list, destroy the list, print the results, or print the list. Okay. So we can define this, and this is the abstract behavior. When it comes to the implementation, we can do it as a class. In fact, classes in C++ were designed to allow us to implement abstract data types. Okay. So we couldn't do this with a struct because of all of the operations. So let's take a look at how we could do this. So note that this is all I've got. I'm just putting this out there as the start. we'll probably work on this for a homework assignment. But I've got my class list type. I've got the private data is going to be a list. In this case, we've made it a list of 1,000 integers. Okay. Again, we're improving on the array that's built into C++ by including a length function. So now we can refer to our list.length, and that will return a value. Okay. So the functions we want are just the ones we came from up there. And we've got our Boolean function is empty list, is full list. Those are constant. And I forgot, and I know a lot of you are going to forget, so we'll have to go back and look at it. We need to look at this on all of our functions we create. Okay. In particular, accessors are always constant. And I didn't do that, so I'll go back and correct it. Our search function is constant. It doesn't change things. So here's a search with an int on search item. Insert and remove both change the list, so they're not constant. And we're going to insert the int new element, and we're going to remove int remove element. We've got a destroy list function, which doesn't take any parameters. We've got a print list, and of course the destroy list changes the list. The print list is also a constant function. And then here we just have a constructor that sets it up that way. So this is the abstraction, or it's the start of an implementation of that abstraction. So again, probably you'll see that for homework. So now let's go back to our class program because we didn't do it correctly. So here is where we have to think about these things. Oh, they are there. Well, look at me. That's the version I did before that. I don't think I did the version I did today. No, I just did that one. No, that's not. Now I'm talking to myself on video. That's exciting. Let's see if I did it here. I did not. This is where I didn't do it. Okay. So again, accessors, always constant. Set, the mutators are not constant. Area is constant, doesn't change anything. And print is constant. That's all we got. The constructors, of course, are not constant. Okay, so that's fixed. So yeah, you've got to remember to do that. I've got to remember to do that. Yeah, if we do enough, we will. So we talked about how to create a class, how to go through the habit to create a routine that we always follow in creating them. Start with the private data, have the accessors with a label. So you put a comment for the accessors, for the mutators, the other functions. Look at the constructors. Constructors were new for us. We'll talk about destructors later. How do we test our classes? We talked about making a separate file with just the class definition and including it in a test program. That's all good things as well. And then finally, we finished up talking about abstract data types. So we'll do more of this, one more video on classes. So if you have questions, make sure you let me know.